All right. Our next speaker is Walt Kelly, and he has a recorded presentation. So this should go smooth. And I will take it away, Maggie.
Hello, my name is Walt Kelly. I am the head of the Groundwater Science section at the Illinois State Water Survey, which is part of the Prairie Research Institute at the University of Illinois at Urbana-Champaign. My scientific background is as a groundwater geochemist. Today, I am presenting a study designed to determine if homes with domestic wells are vulnerable to waterborne lead contamination in Illinois. My co-investigators are all public health scientists. The studies I will be discussing today were funded by the Illinois Sustainable Technology Center at the University of Illinois and the U.S. Department of Housing and Urban Development. Many, if not most of you, are probably well versed in lead issues, but I did want to start with some basic information about lead in drinking water. First, lead is a poison. We've known this for a long, long time. It can cause brain and liver damage in both adults and children, but is especially harmful to young children. There are no safe blood lead levels, and the CDC's current level of concern for children is 5 micrograms per liter. Because of all the legacy lead in the environment, all of us in the U.S. have some lead in our blood. Lead in drinking water is regulated by the lead and copper rule, which was recently amended and sets a trigger level of 10 parts per billion for lead at customer taps for public water supplies. However, in most, if not all states, as I'm sure everyone here knows, there is no regulation of domestic wells for water quality once the well has passed the initial nitrate and coliform tests. Studies in several states have suggested that waterborne lead might be a concern in homes with domestic wells, so we were interested in learning if this was also true in Illinois. If you ignore its health effects, lead is quite a useful element and has been used for millennia to deliver water. In fact, plumbing is derived from the Latin word for lead, which is why its chemical symbol is Pb. It is soft and malleable and resists pinhole leaks. In many parts of the world, including Chicago, building codes mandated for many years that lead service lines had to be used. It wasn't until 1986 that this was stopped. As a result, there are a lot of lead service lines in this country. Data from the US EPA reported here shows the estimated number of lead service lines as of about 2013 in each state by US EPA region. Region 5, my region, is especially bad. By this estimate, Illinois has the most lead service lines in the nation with approximately 700,000. Note that this is a log scale on the y-axis. Lead in tap water is mainly from lead service lines, but there are other sources including solder and brass components. Even today, brass fittings have some lead in them, although the allowable levels have been dropping in recent decades. As a result, we're mainly concerned with older homes, particularly those built prior to 1986. In addition to a home's pipes and fittings, there are also potential sources of lead in the well itself, especially older wells, including packers, brass components in pumps, and galvanized metal. Lead can get into water via several mechanisms. One is by leaching due to corrosive water, which is what happened in Flint, Michigan when they changed water sources. Particulate lead can flake off in various ways. Some studies have shown that nearby physical disturbances, such as construction activity, can actually trigger the release of particulate lead into a home's plumbing. A water's corrosivity is a function of its water chemistry. There are many variables that can affect corrosivity, but the most important ones are pH, alkalinity, chloride, and sulfate. There are several different measures of corrosivity, but they all have some limitations. The one we mainly focused on in our study was the Larson-Skold index. With the Larson-Skold index, water is more corrosive with elevated levels of chloride, and sulfate, and lower levels of alkalinity. Another index, the chloride sulfate mass ratio, has been shown to be useful in predicting galvanic corrosion. Our initial study was designed as a pilot study. We identified 3 counties with a wide geographic range in different hydrogeologic settings: Jackson, Peoria, and Kane counties, shown here on the Illinois map. Jackson, Peoria, and Kane. Jackson County is very rural and was not glaciated during the Pleistocene, and its main aquifer is a karst aquifer. Except for the area around the city of Peoria, Peoria County is rural, with most domestic wells tapping glacial sand and gravel aquifers. Kane County is the most urban of the 3 counties, with its eastern corridor being urbanized for a long time and increased urbanization in the central part of the county, the western suburbs of Chicago. Domestic wells in Kane County are finished in both glacial and shallow bedrock aquifers. We focused as much as possible on older homes, assuming that they would be more likely to have lead issues, and there were 2 phases to the study that I'll mention shortly. We worked with the local health departments in each county to recruit participants, focusing on maximizing the number of older homes. The local health departments were key and invaluable partners in the project, and it would have been much more challenging without their assistance. They received funding from the grant and were responsible for advertising, screening potential participants, and going to their homes to train them on collecting the samples. We did not share individual results with the health departments, just aggregated data with personal data scrubbed out. This was to assure the homeowners that nobody from the government would be shutting down their wells, and that what they did with the results was their decision. And in the end, we had 151 participants. In phase 1, the health department personally trained the homeowners to collect samples from their kitchen tap after a period of stagnation, which was a minimum of 6 hours. The health department staff gave the participants an insulated shipping container that contained 2 1-liter labeled bottles, nitrile gloves, a freezer pack, and a UPS return shipping label. There was also paperwork, including a consent form, a questionnaire about home, well, and water use, and written instructions. In addition to the instructions and the personal training by the health department, we also made a video of the sampling protocol, including a Spanish language version. To collect samples, participants put on gloves and collected a first draw sample, the first liter coming out of the tap. Then, using the second bottle, they filled and discarded the next 5 liters of water, and then collected the 7th liter, which was assumed to represent a relatively flush sample. Samples were picked up at the participants' homes by UPS and shipped to our analytical lab at the Illinois State Water Survey in Champaign. We analyzed for total lead in all samples and dissolved lead in a subset, mainly those with the highest lead levels. We analyzed for the major corrosivity components, alkalinity, chloride, and sulfate, in the 7th liter sample. The homeowners filled out the questionnaire about their home, well, and water use and put it in the shipping container. Once the analyses were complete, the homeowners received a lab report and a letter explaining their results. If they were concerned about the levels of lead in their tap water, they were instructed to contact their doctor or the local health department. In phase 2 of the study, we returned to the homes with the highest lead levels. The homeowners resampled at their kitchen tap just as before, and we collected a purge sample from their well at a location upstream of any treatment. We collected field parameters during sampling, including temperature, pH, dissolved oxygen, specific conductance, and oxidation reduction potential. Copper was also analyzed as well as lead in phase 2, and a complete inorganic chemistry analysis was done for the well water sample. So here's some questionnaire results which were of interest. The vast majority of participants, about 93%, were aware of the lead issue in Flint, Michigan, although a much smaller percentage, 64%, were aware that water is a possible source of lead. This seems odd that many people apparently didn't connect that the problem in Flint was lead in the drinking water. It's possible that the question wasn't clear enough in the questionnaire. Most of the wells in the study were drilled, although almost a third of the participants didn't know what kind of well they had. This lack of knowledge about one's well is pretty common, as I'm sure most of you know. You can see that a majority of the homes and wells were built pre-1986, although only a few of the homeowners, about 17%, were aware of lead components in their plumbing system. It's also of interest that most well owners put very little money into their well, less than $100 per year to maintain it. We asked some questions about the participants' perceptions of water quality. Only about 75% of them agreed with the statement that my tap water is safe to drink. And also, almost 40% said that they agreed that their bottled water was safer than their tap water. So this table summarizes the total lead results from phase 1, with the top row of each county showing the first draw results and the bottom row the 7th liter results. There was some variability by county, but trends were generally similar among the 3 counties. Almost half of the homes had detectable lead in their first draw, and 23% had detectable level in the 7th liter sample. Concentrations were almost always greater in the first draw, although not always. Concentrations could be quite high, with 6 of the samples, or about 4%, above the 10 parts per billion trigger level. The highest concentration we measured was 76 milligrams per liter in a Jackson County home. This table shows the corrosivity results for each county, showing the median, maximum, and minimum values for alkalinity, chloride, and sulfate. You can see some clear differences in chemistry among the 3 counties, with Jackson County having significantly lower alkalinity and chloride. Kane County had the highest chloride levels, but also relatively low sulfate levels. This high chloride levels in Kane County is most likely the result of de-icing salt runoff. So using threshold values of 0.8 and 1.2 for the Larson-Skold index, the majority of the samples in all 3 counties to have relatively low corrosivity, about 80% per each county. Results from the chloride-sulfate mass ratio were quite different, with the majority of samples having high corrosivity, especially in Peoria and Kane counties. This is mainly due to the increased chloride levels in these counties, especially in Kane County, again, due to the de-icing road salt runoff. Statistical testing indicated 2 main results. First, older homes were more likely to have detectable as well as elevated lead levels, which is what we expected. Second, older homes with corrosive groundwater as measured by the Larson-Skold index were especially prone to having detectable lead. The chloride-sulfate mass ratio was not predictive for our data set. This plot shows particulate versus dissolved lead concentrations for the subset of samples with the highest lead levels. So the dissolved lead on the x-axis, particulate lead on the y-axis. We got the particulate concentrations by subtracting dissolved lead from total lead. The line shows the one-to-one relationship between dissolved and particulate, so that symbols falling above the line indicating the lead was mainly particulate, and falling below the line mainly dissolved. For almost all of the samples, there was both particulate and dissolved lead. And for the samples with the highest lead concentrations, most of the lead was in the particulate form. Those 4 of our samples had lead concentrations greater than 30 micrograms per liter, and for these samples, the lead was almost all in the particulate form. In phase 2, we collected samples from the well in addition to the kitchen tap samples, and you can see in these plots how lead levels decrease from the first draw to the 7th liter to the well sample, highest in the first draw, lowest in the well sample. This is true for all 3 counties, and this indicates that the vast majority of lead coming into the drinking water is coming from the plumbing system. There were, however, a few wells in Jackson County that had detectable lead in the well water itself. We also measured copper concentrations in the phase 2 sampling, and this slide is pretty similar to the previous slide for lead, but this showing the copper concentrations, again showing the highest concentrations in the first draw sample, lower concentrations in the 7th liter sample, and the lowest concentrations in the well sample. And we only had one sample above the 1.3 action trigger level for copper concentrations. So again, showing that most of the copper as well as the lead are coming from the plumbing system. The lead and copper concentrations were not well correlated in the phase 2 sampling, either for the first draw or the 7th liter. This suggests either that there are different sources for the 2 metals in the plumbing system or that the corrosion reactions are different. So this plot shows lead in first draw samples from wells that were homes that were sampled in both phase 1 and phase 2. Symbols falling on the 1-to-1 line indicate that the concentrations were the same between the 2 phases. I think you can see that for some homes there were large differences in the 2 sampling events. This indicates there can be considerable temporal variability in lead concentrations. This was especially true for the samples with the highest lead levels in phase 1, which were primarily particulate lead. The large decrease in lead concentrations for phase 2 sampling for these samples suggests that particulate lead may be a more intermittent issue. This also highlights the difficulty of replicating results, especially when dealing with particulate lead. One variable we found to be of interest was pH, which was measured in the well water in phase 2 sampling. Jackson County, which has a karst aquifer in much of the county, had particularly low pH values during phase 2 sampling, as indicated by the red triangles. These samples were collected following a relatively wet period and shows the rapid movement of rainwater through the aquifer with little time for buffering. In addition to having detectable lead, these samples tended to have elevated dissolved oxygen and nitrate levels, further indicating rapid and young recharge. As a result, this water was very acidic and corrosive. As you may recall, there were several homes in Jackson County that had detectable lead in the well water itself, which we are attributing to the acidic water. So a few conclusions from the pilot study. We have published a final report and a paper with the citation at the bottom there. Our results confirm studies in other states that homes with domestic wells, especially older ones, can be vulnerable to lead contamination in their water. Second, an understanding of the hydrogeology and geochemistry of the source aquifers is important. Changing water quality, such as the rapid recharge we saw in Jackson County and the de-icing salt runoff in Kane County, can affect water corrosivity. And based on questionnaire results and our interactions with the homeowners, it's our belief that domestic well owners need assistance in dealing with problems such as lead contamination. In 2020, we started a follow-on study funded by HUD. Unfortunately, the pandemic hit just as we were getting started, and health departments had to devote almost all their resources to that, and thus progress on our study has been slow. And as a result, we're not quite ready to present any of our results. We've added 2 new counties, Champaign in east central Illinois and Whiteside in northwestern Illinois. And then we're going to do phase 1 sampling and analysis in those counties as we did in the previous 3 counties. But for these 2 new counties, we've expanded the sampling to help assess how variable the lead results may be. The other new parts of the project involve plumbing and well assessments and providing and evaluating lead mitigation measures. The goal of the plumbing and well assessments is to determine potential sources of lead in the systems. Our partner for the plumbing assessments is the Illinois State Department of Public Health, And for the well assessments, our primary partner is the Great Lakes Community Action Partnership, or GLCAP. Our sampling in the pilot study and follow-up modeling has suggested that single samples might not be adequate to assess a home's vulnerability to water-lead contamination. For the two new counties, we're requesting the homeowner sample on 3 consecutive days to give us a larger data set to evaluate. We had to modify the sampling protocol slightly in order to fit all the bottles into the shipping containers. Now there is a single 1 liter bottle and 7 labeled 250 milliliter bottles. The homeowner fills the 1 liter bottle with the first draw, then transfers water to the first 250 milliliter bottle and discards the rest of the water. The 1 liter bottle is then filled and emptied 5 times. Then after the 7th liter is collected, sample is transferred into the second 250 milliliter bottle from the 1 liter bottle, and the rest of the water is then again discarded. And then this procedure is repeated for the next 2 days. The 7th 250 milliliter bottle is given to the well inspector when they come out to the home, and they collect a purged well sample upstream of any treatment. Then all 7 250 milliliter bottles are shipped to the water survey lab. The other new thing we're doing in this follow-on study is evaluating some mitigation measures. So the 20 homeowners from each county with the highest lead concentrations will receive one of 4 measures that will be selected randomly for them. These measures will be provided free of charge, and their performance will be evaluated over a years-long period. So the 4 treatment options are full replacement of lead-containing components in the plumbing in the well, and this will be done by licensed plumbers or drillers, or both. Second is reverse osmosis. Again, this will be installed by a licensed plumber. Certified POU filter device, point of use filter device, again installed by a licensed plumber. And finally, a water pitcher with a Brita style filter. So if you're not familiar with these point of use devices, these are some recommendations that US EPA has about them, making sure that they're certified under NSF ANSI standard 53, which should be on the box that it comes in or actually on the device itself. They are designed for homeowner installation, but in our project we're having a professional install them. And we always recommend sampling before and after installation to make sure the device is doing what you want it to do. And of course, as is true with any kind of treatment device, you got to make sure it's properly maintained. Otherwise, they will stop working. So I like to end most of my presentations with the plug for the privatewellclass.org. There are a lot of resources on lead on this website, so I would recommend, if you have an interest, to check it out. So, and thank you very much for your attention.
Thanks, Walt. Right now, we don't have any questions, but I don't know if there's anything you want to add. I know we were talking this morning about one of the reasons well owners don't test related to what to do once they find it. And so I think this is a unique study in that respect, what you're going to do anyway, especially replacing all the plumbing in somebody's home. It's a really novel type of project. So it's we're looking forward to hearing what happens. We do have a question from Eric Yegi. Are the RO systems certified to remove lead under 58? Not all RO systems will remove lead.
I don't know. Do you know, Steve?
I don't.
Good question.
Yeah, it's something you probably need to check into. I know I thought one of those was for RO. Yeah, maybe you just meant, is it possible that you meant to put 58 and you put 53?
It's possible.
Because I think 53 is for filter devices. And Eric's the person to ask that question or answer that question. But I know there's really 2 methods, and yeah, RO does not work. Oh, well, I'm thinking of arsenic. Never mind. Filters. Yeah, so he's put another note up here. It said filters are under 53, but ROs are under 58.
Oh,
So,
okay.
yeah. And so I think that's all it is. Yeah. Okay. So it's, yeah, they meet the standard for lead is what you're after for RO.
Right.
Yeah.
Yeah. Mhm. Yeah, we don't want to give people something that's not
right.
designed to remove lead.
And so, and you're not to that part yet of the study. So,
correct. Yeah. Probably next year at this point.
All right. Well, thank you. If anybody has any further questions, you can email Walt or let us know.
And I noticed that Cindy Brooks is attending, and she's working on our project with us. And so, if you have any questions about the well assessments, I'm sure she'd be happy to answer them.
Yeah, as some of you may or may not know, through the program that RCAP manages, which funds the private well class, the 6 regional affiliates of RCAP, which Great Lakes Community Action Partnership is one of, are doing well assessments all over the country. So I know a number of, Joe Fields is here from SIRCAP. I saw William Hood from Communities Unlimited, and Jesse Campbell from MAP, and Cindy is from, again, GLCAP. And so they're actually in the field doing assessments in their regions, as well as the other 2 that, and our next speakers are from RCAP Solutions, which is the Northeast RCAP. Jim Starbird is one of the folks doing all those assessments as well. It's a great program. It's a really thorough assessment, and they've done close to 3,000 of those around the country since we started. So it's pretty cool.